In this video, I am going to go over the facts that you should have memorized by the end of your first semester of AP Calculus. You can use this video like flashcards and pause the video each time, try to guess the answer on your own, and then play the video and see how you did. Let's begin. The derivative of a constant is 0. If you have x to the n power, you take the derivative using the power rule. So the n goes to the front, and then you reduce the exponent by 1. So you would have n minus 1. To find the derivative of a product, we use the product rule. So the first time through, I will take the derivative of the first factor. So that's why I will write f prime of x. And I leave the second factor alone, so g of x. And then I put a plus, and I go through it again. The second time through, I leave the first factor alone, so I have f of x. But I take the derivative of the second factor, so I have g prime of x. And that is the product rule. To find the derivative of a quotient, you use the quotient rule. In my head, I always quote the quotient rule poem. In this poem, when I say d, it means the derivative of something. So low d high, less high d low. Draw the line, and down below, the bottom squared will go. Here's what that means. Low d high. Low is g of x. And d high is f prime. So that's low d high. Less means subtraction. Low d high less high d low. High is f of x. D low is g prime. So low d high less high d low. Draw the line, and down below, the bottom squared will go. So there's your quotient rule. The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. The derivative of secant is secant tangent. The derivative of cosecant is negative cosecant cotangent. If the derivative of tangent is secant squared, then we know the derivative of cotangent will be negative cosecant squared. The derivative of arcsine is 1 over the square root of 1 minus x squared. Please note that arcsine and inverse sine are the same thing. What about the derivative of arc cosine? It's going to be exactly the same as the derivative of arcsine, except it will have a negative 1. So here is the derivative of arc cosine. Arc cosine is the same thing as inverse cosine. The derivative of arc tangent is 1 over 1 plus x squared. So there's no square root, and it is positive. Arctangent is the same as inverse tangent. The derivative of arc cotangent is the same as the derivative of arctangent, except for it has a negative 1 in the numerator. So negative 1 over 1 plus x squared. The derivative of arcsecant is a little bit odd because it has an absolute value in it. So I have 1 over the absolute value of x, and then the square root of x squared minus 1. If you compare this to the derivative of arc sine, notice that arc sine has the x squared on the right, so we have 1 minus x squared. But arc secant has the x squared on the left. I remember this by thinking to myself that when you have two x's, they like to be together. Aw. The derivative of arc cosecant will be the same as the derivative of arc secant, except for the negative 1 in the top. So we will still have the absolute value of x, and then the square root, and the x's still like to be together, so we put the x squared first, and then the minus 1. The derivative of e to the x power is my favorite derivative because it is simply e to the x power. The derivative of a to the x power is similar. It will also start by repeating itself, a to the x power, but we have this extra piece where we do the natural log of a. The derivative of natural log x is 1 over x. But what about the derivative of a regular log x, a log base b of x? You can think of it as starting out as 1 over x, just like natural log. But then we have this extra piece where we do the natural log of the b. When you take the derivative of a function inside of another function, you use the chain rule. And we've learned that you first take the derivative of the outer function, which would be f. So we will have f prime. And you leave the inner function alone. But then the chain rule says multiply it by the derivative of the inner function. So g prime. So this is one version of the chain rule, but there's another way of expressing this that often is more useful. So this is the derivative of function f. And if you want to take the derivative of f with respect to x, you could write that as df dx. So the chain rule says that df dx can be sort of split apart in the following way. I can have my df in this numerator and my dx in this denominator. I can basically put whatever I want in these two empty spaces as long as they are the same, because they would essentially cancel each other out. But in this case, we're going to use the inner function. So this becomes df dg times dg dx. Now, if you think about it, you can see why this is the same as what we had here. Because we're saying that the overall derivative of df dx is the derivative of the outer function, which is the derivative of f with respect to g, and that's what you see right here, times the derivative of the inner function, the derivative of g with respect to x. There are certain problems which can be expressed much more easily using this version of the chain rule. So make sure that you know both of these. So that's it for the derivative rules. Here are some relationships that you need to have memorized by the end of first semester. What's the relationship between the velocity and position? Velocity is the first derivative of position. Now, what's the relationship between acceleration and position? Acceleration is the second derivative of position. So what's the relationship between acceleration and velocity? Acceleration is the first derivative of velocity. What are the two situations when speed is increasing? It's all about velocity versus acceleration. Speed is increasing if the velocity and acceleration are both positive. So that means that v at t is greater than 0 and a at t is greater than 0. If velocity and acceleration are both positive, speed is increasing. But also, if they are both negative. So if the velocity is negative and the acceleration is also negative, still the speed is increasing. So in short, if the velocity and acceleration are working together, the speed is increasing, regardless of whether that's in the positive direction or in the negative direction. If they're both sort of pulling in the same direction, the speed is increasing. Vertical tangents occur when the first derivative is undefined. Horizontal tangents occur when the first derivative is 0. The next three questions are better represented by the information on this chart. So basically, you need to memorize this chart reflecting the graphical relationships between f, f prime, and f double prime. So for number 7, when I ask if f prime is decreasing, then what's happening to f double prime? If you look at it in terms of the chart, if f prime is decreasing, then that means that f double prime is negative. Number 8, if f is concave up, then what's going on with f double prime? Let's look at the chart again. If f is concave up, then f double prime is positive. And number 9, if f prime is positive, then what's happening with the original function f? If f prime is positive, then f is increasing. I could go on and on with questions like this, but the bottom line is know this chart inside and out. In fact, I would recommend that at the beginning of a test or a quiz or even the AP exam, you should write down this chart quickly in the margin of your paper or on a sheet of scratch paper, and then refer back to it because many questions will use this information. The last two things I need you to memorize are the traditional definition of derivative and the alternative definition of derivative in terms of limits. Here is the traditional definition. If I ask you to write down the traditional definition of derivative, you should be able to just write this down off the top of your head. Now, do you know the alternative definition of f prime at c? This one starts out as the limit as x approaches c, and then it is sort of an old school slope with a y minus y over x minus x. The y minus y is f at x minus f at c, and the x minus x will just be x minus c. As I memorize these two, it helps me to note that both forms have f at c sort of in the upper right hand corner. So use that as an anchor and then write the rest from there.